Good morning, good afternoon. This is Ahmed Mahmoud from DataMindAI. This session is part of the Lakeflow um, Masterclass, and we are going to focus today on the pipeline, Lakeflow pipeline. And we have done a session on Lakeflow Connect, and today is going to be on the pipeline itself. As we know, Lakeflow have three sections, like the Connect, Lakeflow Connect, as you call it, ingestion pipeline, and then we have the ETL pipeline or the pipeline themselves, and then the job. You have these three parts. So we've seen the ingestion pipeline before. We just covered it extensively. We saw it how to ingest, for example, SQL, Oracle, MySQL, and so on. And today we are going to see the pipeline. So let us dive in. Now, the Databricks Lakeflow Spark Declarative Pipeline is a new one, not new, but it had been like upgraded. We used to have the DLT before, and I think since a couple of months ago, the Databricks they're promoting this Lakeflow Spark Declarative Pipeline. They just add the Spark on top of it, meaning they used to have like DLT, which was proprietary, and now they are moving to the open source, which is Spark. So the declarative pipeline is now in Spark instead of the DLT, the proprietary one. But the functions are similar, and they're not like much difference apart from the syntax here and there. Now, so this is the one we are going to cover. This is the introduction. So what I'm going to do is, like, instead of overwhelming you with a lot of information together, I'm going to break it down into small chunks, sessions, probably short sessions instead of one big one. So the first one is going to be an introduction, and then the second session is going to be focused on stream tables, the bronze layer. And then we are going to see the materialized views, third session. And then we see we are going to spend the data quality expectation as another session and how to use them. Now, and then the fifth session is going to be medallion architecture. And then we'll have 6, 7, and 8, which is CDC, migration, and best practices is going to be together, as a sixth session. So we'll have 6 sessions altogether. But what we'll do is, like, each session will have its own outcome. And from today, the outcome from today is going to be to understand the difference between imperative and declarative. Why does it shift? What is the advantage for the declarative pipeline? And then we are going to touch this again, the Lakeflow Spark, the new one, the one they have introduced. And we have an example as well, example of one pipeline, just to finish it. So that is, we need to take, today we want to have like a clear understanding of why we need declarative pipeline. That's the outcome we wanted from today. Now, we will cover the paradigm shift, as we said, and then we'll have like the ecosystem, the Lakeflow ecosystem, the Connect, the pipeline, the jobs. And then we are going to have like the first declarative pipeline. We'll see what does it look like in general terms. And then the decorators, we'll just spend like 1-2 minutes about the decorators, because they are very important when writing your code in Databricks. Now, what is the difference between imperative and declarative pipeline? The old way, which is it is, let's, if you have an analogy here, it is the difference between recipe and the menu. So if you want to cook something, you can either see the recipe and start cooking one by one based on the recipe, or you will have a menu. You say and then you choose the food you like. Yeah. Say, for example, if you want to do like burger, so you need to have like either a recipe for burger, and then you go to the shop, buy meat, buy this, buy that, and so on, and then how to fry them, and you do them step by step. Alternatively, you go to a restaurant, you will have a menu, different kind of food, and then you choose, for example, burger out of those menus. So this is the difference between imperative and declarative. In terms of code, the imperative program, you will tell the system how to do something step by step. Yeah, that's what you do. So you tell the program, do this, and then do this, and then this. Say, for example, if you want to create, like, you want to create material as view, yeah, or some kind of a table. Now, what you say is like, first read this one, read from this place, and then you say, do this one onto the table, and then the third step will be write this one into this location. So step by step, you tell the program what needs to be done. Now, the problem with this approach is, first you need to manage the execution order, as you see here, execution order, and then you need to handle also dependency yourself, and then you need also to retry logic. You need to to write the retry logic if something failed. The incremental processing also, you need to manage them, and then you have error requires custom handling as well. So everything here you need to do it by yourself, because it's like a recipe. You just you need to buy each one, and then you need to know how to do them in order and cook them. Yeah, and then they become a meal. But that's the problem with having a recipe. It might not be the right taste, it might not be the right ingredient, it might not be this, and so on and so forth. So you need to do it all by yourself. While the other one, you need to depend on the chef. Chef will do for you. Just he will tell you the menu, what he has, and or what she has, and then you need to choose from there. So in declarative programming, you tell the system what you want, like your wish list, and the system figures out how. Yeah. So it is not you who need to do this, how to do the system. The one who says how to do error handling, retry logic, incremental processing, all this stuff. Yeah, it's not your concern. Just you need to say to system what you want. Yeah. So, for example, in here, for example, you want to create a materials view, and you want it to be named row customer, and you need to have a filter called status to be active, group them by customer ID. This is your wish list, yeah? That's what you want. And the system will know how to do it for you, yeah? So the benefit of this one is the engine manages execution automatically, and then dependency are not inferred from table, yeah? So the dependencies are inferred from table references, yeah? Which one is which, yeah? So the table are a key part here. Now, it will be also automatic incremental processing, built-in retry and error handling, and optimized compute resource allocation as well. Yeah. So the key principle here, like, stop writing the recipe, start ordering from the menu. That's what you're doing. Yeah. So now the Lakeflow ecosystem is here. We have, as we said before, we have three, in the Lakeflow ecosystem, we have three of them. One is the Lakeflow Connect, which is the ingestion. We saw that how to ingest from different sources, from MySQL, from Postgres, from Oracle. And then also we saw, not in theory, we saw there's also a couple of enterprise applications as well, which you can ingest from. For example, ServiceNow Workday, Salesforce. You can also, we saw this one also, SharePoint, unstructured data. Yeah. So, and then you have, this is the Lakeflow as a whole. You have the Lakeflow ingestion, connect, and then you have the pipeline, and you have the Lakeflow jobs. Yeah. So the Lakeflow pipeline here, the declarative one, is a Python file using @dp decorators. It is this one is an evolution of Delta Live tables, DLT, as we said before, and the future as it has automatic orchestration, incremental processing, compute outscaling, data quality enforcement. Yeah, and then the Lakeflow job is like reliable pipeline orchestration, support triggers, branching, looping, full lineage tracking throughout the utility catalog. So that's the job, the Lakeflow job. So just to recap the connector. So what we've done, what we saw before was like the Lakeflow Connect is like you start from the source databases, for example. The database could be on-premise, on cloud, could be SQL Server, MySQL, Oracle, SharePoint. The transaction data, this is the source data. This lives there, and you need to enable like CDC, for example, yeah, for streaming on those databases. For example, we saw MySQL, how to enable that functionality. You need to go to MySQL to enable the CDC on that one. So this is the source data. It could be on-premise or in cloud. And then the Lakeflow Connect is like it has an engine, which is called ingestion gateway, which it requires like a compute source as well to move the data from the source into a staging in Databricks. Yeah, so the staging is a volume. Yeah, it's like a landing zone where you land your data. There is a volume there. So the ingestion gateway, which is it requires classic compute, it moves from the source into this staging stage, which is managed by Unity Catalog, or it is part of Unity Catalog volume. Now, the ingestion gateway connects and extracts data with native CDS support. Yeah, so it has, and therefore it has persistent connections, and then it puts them in staging, which is stores raw files and CDS checkpoints. This is a key, a list of like an indication that the checkpoints, so that it does not, you don't need to retry, you to copy again and again. Yeah, you can start from where you stopped. For example, there is a failure. Yeah, so durable intermediate layer. This is the Lakeflow Connect, and then you have this ingestion pipeline, which we are going to talk today, and it requires like the service compute. It transforms and writes to optimize the delta tables. Yeah, this auto scaling execution. In a nutshell, from the volume catalog volume, it will be copied to a delta tables in Unity Catalog. Yeah, it is from Unity Catalog volume to a Unity Catalog but delta table. That's what the ingestion pipeline is going to do. Now, this is what we spend a bit of time there. I think I spent a session on this Lakeflow, and then you have this Lakeflow Spark Declarative Pipeline. Yeah, which have, if you see it in a nutshell, yeah, as a big picture. Remember, we're saying from volume to delta lake. Yeah, this movement is done via this medallion architecture. Yeah, that is what the pipeline is going to do. So from the volume, it will put data into the landing zone. Yeah, into bronze. This is one function. So row is ingestion with autoloader now. So it will see on the volume all the data change which is happening. Yeah, quickly it is going to look at it, and then it will through this autoloader mechanism. We are going to look at it as well in much details, but just to give you an overview of what is happening. So the pipeline is, as we saw, is the bronze to silver to gold. So the bronze side, it was incremental file ingestion. you have schema inference, you have rescue column for drift, you have exact ones processing. This is the bronze layer, yeah? The bronze side. And then on the silver, you have clean and validated with expectation. It does like typecasting, deduplication, data quality rules, anomaly filtering. And the gold is like business ready data, and it is aggregated data. Well, you have the main side here is like to have risk calculation, to have data quality gates, yeah. So if the data quality is wrong, it fails, it stops, it doesn't go the gold, yeah. So there is a gate which is very fundamental here. But an overall, this is the area of the pipeline. Yeah, this is an overview there. Now, if you go now to what you were talking about, this is the ecosystem. Now, the when you see, for example, the pipeline, I say it will have ingest raw data, which is the bronze, clean and validate, it's in silver, and business metrics in gold. Yeah. So in a nutshell, you can see, for example, here the first part here. Again, we are using this one. I think it's wrong. It should be PySpark import pipeline, and then you have these decorators here. This is the first one. Is the bronze layer. Yeah. The bronze one here is in here. So what you are doing is you are decorating the function here, your what you want, yeah. What you want is you want like streaming table for continuous ingestion, yeah. That's what they need. Streaming table for continuous ingestion, yeah, because the data is going to come continuously, and you need a table which can hold this continuous ingestion, yeah. And you are going to use autoloader to automatically detect new files. So on the source, you need to find out what is happening, if there are any files coming, new ones, yeah, new updates or new deletion or new insertion. So if that is happening, then you need to be notified, Databricks need to be notified. So this notification or this monitoring and notification is done through this autoloader. And this, once data is coming there, it will automatically detect the new file, and then the streaming, the continuous integration will happen. Yeah, and then you will say, for example, you want a streaming, functionality. That's what you are saying here. Read the stream. You are not saying read CSV or read anything else, but what you are saying is like read the stream. So this is streaming data, and you are using these cloud files. Cloud files is the autoloader now. This is the autoloader is cloud file. This is the one which is what detects new files, and they arrive, and then you are saying the files you are is going to be JSON. That's what you are expecting, and then you want to the schema location. So what will happen is like it will infer the data, the type of the column, whether it is a string or date. If you don't infer it, it will the system will automatically bring everything string or text. Yeah. So this is again for example, if it is money, it will come like for example £5. It will come like 5 string, which doesn't make any sense. So you need to infer that one. The system needs to infer that the type. What is the type of the data which is coming? And then the result of that inference need to be placed somewhere so that you don't need to infer again and again. You need to place, and you need to put a location for it. This is the location for the schema location. Yeah. So the schema location is in here, and load it into this place. Yeah. So load from here and put it in the table. That's the whole idea of this bronze layer. Yeah. So the bronze layer is ingestion data, and as we were saying before, it is like incremental file ingestion schema inference. You see, yeah, rescue column for drift and exact ones processing. I haven't done here just because it's going to be like an introduction, but you can see what you can add all these options here, a list of options which you want. Yeah, we are going to spend much time when we reach the streaming of this one. So this is the streaming, as you can see here. Yeah, this is bronze, and then you go to the silver. Yeah, silver layer. As you said, this is the pipeline will follow this medallion architecture: bronze, silver, gold, and in each one you write your code. Yeah. So we saw the code for bronze, and for silver you want it to be clean. This is the time of clean up. So you need to validate the data in order to clean them, right? Validation is a key part here. So you want like a valid amount should be, for example, greater than 0. You don't need negative value because money is shouldn't be negative, and therefore you are saying you are expecting. This is again a decorator, as you can see, decorated expect. We are going to look at it as well later on the fourth session. The decorators, yeah. This is the decorators you are using. You are seeing you don't want amount greater than 0, and you say drop or. But here, what you are saying is you are not dropping or failing. You are saying that you need to have a warning and put it in if it's greater than 0. Yeah? Yeah. It depends what you want to do. You can say drop if it is greater than 0. Yeah, because it is useless. And the validate data, sales data is not null. Yeah, it shouldn't be null. The sales date, the date should always be there. And then this is the silver. It is we are saying now docstring. This is, as you can see, these three quotation, and between these three quotations, you can see three quotations in between them. It's called docstring in Python language, and this is you notify the system, in this case Databricks, yeah, what is going to happen. So if you just clearly say what you are going to do with this function, so this is going to be materialized view with data quality rules. Yeah, and then logs warning if amount is that's what you are saying. Drop rows with nulls. Yeah, that's what you're saying. So you are saying as a docstring the one you want to happen. Now it's just read. Yeah, read from a table because you already put it there. You can also put stream if you want to, but here because our table is like a stream table as well. Don't forget that one. But we can say like read here, just let us put it this way. And then you want like a specific fields from that table. You don't want to, probably it might have 100 column. So you want to just 5 of them. Yeah, that is and then drop duplicate and base it on sales ID. So if there is 2 sales ID the same, yeah, drop them. That's what you are saying here. So the system will clean up, yeah, as you can see here about valid amount, the date here, yeah, and the duplication will be dropped as well here. So this is the cleaning stuff, clean and validate cells, yeah. You don't want duplication, you don't want like something which is not correct, yeah. So once you do the duplication here, this is the gold, third layer, as we said here, the gold is the aggregation and decision ready. Yeah, decision ready. The KPIs are here. So again, you say aggregated business ready dataset automatically refreshed when silver sales updates. Yeah, so that is it is based on silver sales. Yeah, they are linked. Can you see the dependency of this gold? It depends on the cells which are being created in here. Sales silver. Yeah, and also this one is also depends on bronze cells here. Yeah, that's the dependency we're talking about. Yeah, so that they are linked together through these files or through tables, sorry, in this case. And this is the aggregation. You need to do the counting, the sum, count these things, and so on and so forth. Yeah, and order them by date. So this is the gold layer. This is again, it is decorated. This function, gold daily sales, is decorated by this materialized view. Yeah, and I just explained what materialized view is like. So therefore, we are saying, can you please modify this one, based on this one, or change the behavior of this one with this function, with this one. Yeah. So this is the decorator, which is changing this one into materialized view for you. So it's not a normal, as I said, view. It's not a normal query. Just you are specifying it's going to be materialized view, right? So now the pipeline, yeah, the engine automatically infers that silver cell depends on bronze, yeah, as we said before. Gold daily cells depends on silver. No need to explicitly define the DAG dependencies, yeah. You don't say this depends on this and so on, but the system will know based on the table you specify they are dependent on each other, yeah. Now, incremental processing is like the bronze cells, for example, process only new files since last checkout, yeah. So there is checkout there. It checks the checkout, and since the last checkout, it only processes the new ones. Yeah, and silver engine decides full refresh with incremental. So in the silver, it depends whether you need full refresh or incremental. Yeah, and the gold daily says updates only when upstream data changes. It can only update, as I said before. Also, there is a get there. If there is something wrong, it is stopped. It doesn't work. Yeah. So this is it depends on all this data when they are ready. Then the gold daily sales will kick off and start working. And the data quality here is the expectations, which run automatically on every update. Now, the failed expectations are logged but do not block processing. And use at dp.expect or fail for critical validation. Yeah. So that's the key part. Now, the takeaways here for today, we have the decorator syntax at dp. This is the decorator. All pipeline definition use decorators. For example, at dp.table for streaming incremental ingestion is critical here. This naming is good as well. It's important. At dp.table is streaming ingestion or incremental ingestion. And the dp.materialize view is for batch transformation. And also the dp.expect for data quality rules. Now, the file-based pipeline is use.py files, not notebooks. Yeah. Now, again, this is a new requirement. We are not using any more notebooks for the Lakeflow. We are using .py files, and I will have like the last session. I will have the migration from the old one, the DLT to DP, which one to change. Yeah, instead of just rewriting them again. There's just very small changes which you need to do. I will cover them there, but the key part here is like the Lakeflow, the new edition. We are talking about now 2026, yeah? So in 2026, we are using Spark, the open source, for declarative pipeline. We are using file system.py for not notebooks, and so that is again another change in this 2026. Now, there's also a couple of changes in the data quality, which we are going to look at them as well. Now, we need to enable proper version control, CI/CD, and testing, and also we need to follow software engineering best practices. Yeah? And this is the whole idea of these sessions as well. So we need to take best practice from different disciplines, and we are going to bring them together, how to use them in this Lakeflow. Yeah, that's again, I'm going to have a session on the best practices at the end of this session. sessions, as it were. So you have also this third one is declarative approach. You have decorator, we said, and this is a declarative approach. Yeah, declarative approach is declare what you want, table, view, expectation. That's what you want. Yeah, that's what you prefer, and then the engine determines how to execute them. So automatic optimization and the scaling. So also number 4 takeaway is like we used modern architecture for the pipeline. You have the bronze, which have the raw append only ingestion. You only append. This is immutable. Everything you put in bronze is immutable. You don't change it. You don't update it. You don't delete anything from it. So just so the bronze is only append. You just whatever comes in, you append data into it. And the silver is the clean, validate, and deduplicated. And this is the one which will be used by the data engineers, the data scientists or analysts as well for their work. And the gold is for business ready aggregation. This is aggregated data. The silver is not aggregated, just we shouldn't confuse this one. This one is, as I said, data scientists can use it because it's clean data. Yeah, the bronze is raw. It doesn't mean it's bad data, but it is raw. Yeah, there is no, we haven't done any data quality element into it. Yeah, but the silver, we clean it, meaning we validate it, deduplicated it, so it is ready for people who need them for data science, for modeling, or for analysis, for example. Yeah. But the gold one is, this is the one for business, like your KPI. This is the whole organization. Depend on them, the users, the stakeholders, the executive, everybody who knows, who needs the reports, for example, from that specific function. Then that is the goal is for them. And then you have the Unity catalog integration. The Unity catalog integration is the pipelines are first-class governed objects. Yeah, so they are integrated into Unity catalog, this pipeline, and they are first-class governed objects. It is governed there properly. You have full lineage from source to dashboard. You have automated permission propagation as well. So this is the introduction for Lakeflow. I hope you have enjoyed the session and gained something out of it. And see you next for streaming tables bronze section.